Hi viewers, this is Aimee Kalnoskas with EEWorldonline, and I'm here today with Andy Smith, Director of Training with Power Integrations. And Power Integrations just came off of PCIM, which most of you know is like a major power show. So there's some exciting things that happened there, Andy, I understand. And so let's talk about, first of all, the nature of the show has been generally sort of high power. And Power Integrations has both a lot of low power expertise and a lot of high power expertise. And then also talk about the scale iDriver that you introduced.
Sure. So thank you for the opportunity to talk today. So Power Integrations has been a low power company for many years. About 5 years ago, we got together with Concept, who was a Swiss-based company, and formed Power Integrations in Europe. The PCIM show has always been very important for high power. There's been very, very many high power companies come to that show. It's been very important for things like IGBT driving and those kind of technologies, looking at now things like emerging technologies like GaN and those kind of things are very often discussed there. What we found, however, was that a lot of the customers that we talked to about high power also require low power solutions for bias circuits, for driving different applications within their high power technology. So not only did we find that our high power team was very busy, our low power people at the show, which is mostly me, were also extremely busy with lots of customers coming and asking about low power stuff. And it kind of demonstrated the synergy in power. It's the same at high power and low power. You just have questions. And the same kind of people were asking questions for both groups.
So what would be a typical application that the high power folks were in that they said, okay, we need some help with a low power part of this application?
Oh, sure. We talked to a very large fan company. They're manufacturing blowers for big systems. So they're using high voltage IGBT drivers for the fan systems. But they also have control electronics. For example, a customer was asking about how they could create a 0.7 watt power supply to power a cabinet closure control, so that if somebody opens the cabinet, the system shuts down.
Okay. Very
Very low power, running off a 500 volt DC bus that's designed to deliver kilowatts, in fact hundreds of kilowatts of power. Now this causes us some challenges because now you're running from 500 volts down to 0.7 watts.
Yeah.
It was an interesting conversation, to say the least.
Wow. So we talked a little bit in the past. Well, Power Integrations has a lot of expertise in the packaging and thermal dissipation, right? So how is this translating to the high power market as well?
Okay, so when our companies combined 5 years ago, we did it because we were both working in the power market, and we saw some synergy. The Scale iDriver, which we announced at PCIM, at the 1700 volt version of that device, was a result of a joint design between the two design teams. The team in Germany and Switzerland are very experienced in driving IGBTs, something that we didn't have that experience in San Jose. The people in San Jose are very experienced in communication technology between primary side and secondary side of an isolation barrier. And we developed a technology called FluxLink, which is designed to cross the isolation barrier without using optocouplers or transistors or transformers. It works very effectively in the low power market, but our higher power team was able to take that technology into the high power market. The other thing that we did as a low power company, we were used to shipping very high volumes, perhaps several billion pieces of equipment moving out. RICs are in that kind of volume. The high power team, if they sell 1,000 pieces of anything, it's a really good day. So what we were able to do is take the very high volume packaging technology we developed for low power and actually deploy it in high power applications. And what that allows us to do is take something that is optimally designed for power transfer and move it into a market where you couldn't possibly spend the time and the money to develop a package for high power, high power transfer, because it simply isn't high enough volume to justify the amount of expense it takes to develop a package. So we're able to do that, and that was a really exciting synergy. So we had the two teams talking to each other morning and night. You know, Europe and North America means that either you get up very early or you go to bed very late, and a lot of that happened. So,
yeah, and I guess because you have so many units in the field too, the reliability question was not a question.
That's right. Obviously, when something goes wrong in a high power system, it's quite spectacular. In our
bigger fire extinguisher.
Yes, exactly. In the low power market area, we are able to demonstrate 0.1 ppm failure rates of a lot of our product families. That's a very, very low failure rate. But with a 1700 volt Scale iDriver, the number of failures has gone to the point where there is almost no issue with reliability with our products because they simply work forever. Not quite forever, but for a very long time without issues. That's very important because customers are looking at new technology, new requirements, new ways of solving problems that we're doing now. And to be able to demonstrate that something like an optocoupler that everybody's used for years and years and years, which has been basically one of the only solutions for crossing isolation barriers. Everyone is aware that it has limitations, but they've made it work. Now we come with a new technology approach, this thing called FluxLink. We have to be able to demonstrate to the customers that that is safe. And we're able to do that because we have 200 million systems or more in the field that use FluxLink.
Can you tell us a little bit more about FluxLink?
So what FluxLink is magneto-inductive coupling. Effectively, what we have to do is cross between the primary side of a control circuitry and the secondary side. Now, for high power, the isolation between these two areas is extremely important because you're providing a very high voltage protection level for customers. Reinforced isolation across a 1200 volt system is important because you get the 1200 volts appearing on the wrong side is extremely dangerous. So what FluxLink does is provide a way of coupling information transfer so that you can get data from the secondary side to the primary side and from the primary side to the secondary side. What the high power team was able to do is use this bidirectional technology, which is actually designed to be single directional for the low power products. So they took the technology further.
And how it,
yes, exactly. And how it works is we basically use the structure of the IC itself as both a send and receive technology. It's kind of proprietary, but in simple terms, we don't need optocouplers, we don't need transformers, we simply use the structure of the lead frame of the device to transfer information from primary to secondary and back again. And this gives some lots of advantages. It means that we can do very high voltage breakdown, we have very good galvanic isolation, and we can provide data transfer directly between the two ICs which require the data. So we have some really good advantages for this. And because it's solid state, there is no transmissive medium we need to use, so there isn't a problem with the degradation over time. It's very time stable as a communication mechanism, which is very helpful.
Right. So let's talk a little bit about the markets, and your market has typically been sort of a leader in the high power market, but we talked about some of the changes that are happening, say, in Asia. And so what is spurring those markets on, and how do you see Power Integrations fitting into it?
So obviously Europe has always been very big on alternative energy. It's been growing for a long time. So the 1700 volt scale eye driver we introduced at Electronica was actually to address the growing requirements in the solar market. I'll try and say photovoltaic, but I have a challenge with it. But so
PV works.
Yeah, okay, that's good. So the PV market has been growing quite dramatically, and that's been requiring more high power applications and higher voltage. 1200 volt IGBTs have been very popular for a lot of applications, but moving to 1700 volt means we had to develop a new product, which is why we introduced the 1700 volt scale eye driver at Electronica.
Okay.
The market itself, electric vehicles, we're not in the automotive market today, but the EV market for buses and traction and those kind of things has been extremely strong in its growth. The other area that's growing quickly and developing new requirements, which as a subsystem supplier like ourselves have to support, is things like the DC bus transmission system in China, where now they're looking to put DC, high voltage DC transmission all over the country. The infrastructure in China has been growing for a very long time, but that's carrying on. And also alternative energies are useful everywhere. So we're seeing growth in all regions, in solar, which is useful for this technology, but wind power as well is growing very fast. And some of the other different ideas, as well as industry. The industrial move to higher levels of automation also brings more requirements.
And it seems like it's moving at maybe a faster pace than it has in the past. I mean, we all say, oh, everything's moving so fast, but it does seem like there's more activity in this area.
That's right.
Yeah.
There's many more companies, and the challenge is really keeping up with what our customers are thinking to do. So the exciting thing about working in power electronics, anyway, but in high power it seems to be becoming more prevalent, is that you get to see all the exciting things people are coming up with. And power is never the exciting thing to talk about, but for us, we get to see all this wonderful new technology that's emerging, and that's kind of fun.
Excellent, great. Well, Andy, thank you very much for having this time with us here. We're in beautiful, sunny San Jose with Andy Smith, Director of Training with Power Integrations, and you can research and find out more about Power Integrations. We've got a lot of great white papers and training material on your site. If you could just, the URL of your site is?
Power.com, very easy to remember.
I wanted you to say it.
Okay, fair enough.
Okay, this is Aimee Kalnoskas with EEWorldonline and WTWH Media. And once again, we've been here with Andy Smith, Director of Training, Power Integrations. Thank you very much.
Thank you.